Hello again. I'm Mike Dawn from Hazelcast, and you're watching Tell You Things. I want to kick off a multi-episode, code-intensive dive into our most powerful distributed compute capability. I'm talking about the stream processing engine known as Jet, which is an integrated part of the Hazelcast platform. Jet allows you to define a workflow, which it then decomposes into a series of tasks that it can perform in a highly concurrent manner, utilizing all the available processing power of your Hazelcast cluster. You provide the business logic, but you don't need to provide control flow. You don't write loops or figure out how many threads is the optimal number or worry about how to distribute processing tasks across a multi-node cluster to maximize throughput and minimize movement of data across the network. These are all the things that Jet will figure out for you. Jet provides you with a domain-specific language called the Pipeline API, which you use to declaratively define a series of processing steps which transform inputs into outputs. Here we see a pipeline that implements the popular word count task. Word counting is like the hello world of stream processing, and you can find examples for any stream processor. This implementation and the images on the next few slides I lifted directly from our online docs where you can find more detailed explanations of exactly what's happening at each step. So in the top row here, we see the steps defined in code. Read from source, tokenize lines of text into words, filter out white space, group and aggregate the tokens, and write the results out to the console. Jet will convert this pipeline to a directed acyclic graph, as shown at the bottom. The conversion of the pipeline stages to DAG nodes is not quite one-to-one, as there are a few optimizations applied. This particular pipeline is a simple, straight-through flow, but complex DAGs that involve branching or merging are common, and we'll see some examples of those in upcoming episodes. When our DAG is generated and uploaded to the cluster, each of these processing steps becomes a tasklet that will then be replicated across many CPU cores, and work flowing across the edges between nodes will be buffered in bounded queues that provide back pressure for flow control. Now, there are several routing strategies that Jet utilizes for data flow between nodes. The simplest is round robin, but for data-dependent operations like the group and aggregation nodes, partitioned edges ensure that each data item flows to the correct node, whether that is local or remote. So that's a lot of theory. Let's actually see a real-world example. Every pipeline starts by reading from a data source using the pipeline's read from method. And every pipeline ends by writing to one or more sinks using the pipeline write to method. So the simplest possible pipeline is one that consists of exactly two stages, a read from and a write to. Now our read from gives us a lot of options, and this Jet has connectors to allow us to read from many different data sources, including both batch and streaming sources. There's a test sources, which we can use to make it easier to write simple tests. So here we see test sources gives us several different options, including both batch and streaming sources. And likewise, when we write to our sinks, we can see that the sinks class gives us lots of options of where we can write the data that we're ingesting from our test source. So for this simple example, we're asking test sources to give us a stream of items at 10 items per second. And the IDE is showing us here that those are going to be of type simple event. Now, no matter what source we use, we need to specify what timestamp policy should be in effect because some stages need to worry about event skew or out of order events. And in this case, we're not worrying about that. So I'm declaring without timestamps. Now, in reality, our input events do have timestamps. We're just telling Jet it's okay to ignore them. So this is our pipeline. Read from a test source, write to the sink, and we can run that. Took a second to start up there. And we see it is writing these timestamps out now to the console as we told it. Now, if we're running Hazelcast in client server mode, the code that builds the client or builds the pipeline actually runs on the client, but we want to execute the pipeline on the server. And if we're running in embedded mode as we are here, then the client and the server are same, and it really, that distinction doesn't matter. But to be flexible and to get the code onto the cluster, we want to create and submit a job. And we do that here in our main method. So here we're creating the Hazelcast instance. We get a reference to Jet. We set up a job config, set the name of our job, add our pipeline class to the job config so that it can get transmitted up to the server. And here's where we create our job using the create pipeline method from above and the job config, and we submit that to the cluster. So that's really all it takes to create a pipeline and then submit that pipeline as a job. So now we can look at the Management Center and see this job executing. So in Management Center, we can go to the Jobs tab and see that our pipeline job is running, how many items it has processed so far. And if we drill down, we can see lots of details about the job, including a graphic representation of the directed acyclic graph. As we can see here, we just have two stages, the stream that we are reading from and the sink that we are writing to. Now, most of the time, you're going to want more than just a read from and a write to. So let's add a third stage to our pipeline. One of the fields we can see in our logging output, because job one is still running, is a sequence number. So we can add a filter stage to the pipeline, as we see here, so that we only pass items with even sequence numbers on to the next stage, which is the logger. So let's run this version of our pipeline. And as it starts up, we see that the sequence numbers being output are only the even numbers. So now we're looking at pipeline 2 running in Management Center. We can see that the number of items out is roughly half of the number of items in. And we can drill down into this version and see that our directed acyclic graph now has 3 stages. So over the next few episodes, we're going to create more complex pipelines that better illustrate the kinds of computing tasks that we can do using Jet. But for now, let's quickly recap. We can describe Jet jobs using the pipeline API. Each job begins with a read from stage and ends with one or more write to stages. In between these endpoints, we can add any number of processing stages. They can be sequential, forming a straight through workflow, or they may branch and merge, forming more complex graphs. Management Center gives us the ability to examine the directed acyclic graphs that represent the execution of our pipelines, and we can drill into individual nodes to see the details of the execution. So that's it for today, and we'll be back soon with another episode of TelUvision, where we'll continue looking at features of the Pipeline API.